Hello everyone and welcome back. Today we are going to be doing a problem on coin flips. These are very common problems if you're taking a probability class or if you're trying to prep for some type of quant interview. You'll see problems in this exact format and then you'll see problems that are very similar. So having a good understanding of how to approach a problem like this and how to get a general solution will be very helpful when they ask you this type of question or when they try and go a little bit beyond the normal. But we'll cover the normal and do an example of an extension. But covering the question in general, starting with 2.1, you have a bag of 33 coins. One of these coins is unfair, where both sides are heads. The remaining 32 are fair coins. You randomly pick a coin from the bag, flip it 5 times, and see that each flip lands heads. What is the probability that you chose the unfair coin? So one of the things we're going to cover before we jump into this problem is something called Bayes' theorem and conditional probability. The first one is going to be a way to flip this condition or the information we know. So the probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. Now you can find a derivation for this using the definition for conditional probability and intersections, but I'm not going to cover that. And then another useful formula to know for conditional probability is the probability of A is equal to the probability of A given that we condition on a certain event happening or not happening. So we can split it up into the probability of A given B times the probability of B plus the probability of A given B complement times the probability of B complement. And this is something we're going to use a lot to make our calculations easy. All right, I've copied the question down now. If we jump right into this, we are trying to find the probability that we have the unfair coin, given that we've seen 5 heads. Right, so now we have something in the format of a probability of A given B. So we can apply this Bayes' theorem that we saw before and get the probability of getting 5 heads given an unfair coin times the probability of getting that unfair coin divided by the probability of getting 5 heads in general. Now we have something that we can actually calculate because the first one, we didn't have a way to directly calculate this. So applying Bayes and getting it into this format, we can calculate each of these individual probabilities much easier. So I'm going to write these probabilities down and then we're going to calculate them. All right, so now that I've got these all written down, we can actually start going through them. So the probability of getting 5 heads, given the coin we're flipping is unfair, well, that's just going to be equal to 1 because we're flipping an unfair coin. And then the probability of getting 5 heads, given that we have a fair coin, well, that's just going to be the probability of getting heads raised to the 5th power because we're just flipping it 5 times, multiplying all those probabilities together. The probability of picking an unfair coin, well, there's only one unfair coin, and there's 33 total, so this is just going to be 1 over 33. And then the probability of picking a fair coin, well, you could think of it as 1 minus this. You could think of it as being 32 other coins. Regardless of how you get there, 32 over 33. Now, finally, the last thing we're going to have to calculate is this denominator, the probability of 5 heads. But we have to condition on what type of coin we have because we can't calculate this directly. It depends on what type of coin we have. The last thing we have to calculate is this denominator, the probability of getting 5 heads. So we can't calculate this directly because getting 5 heads is going to depend on what type of coin we're flipping. But we can use what we did before and split it up into what type of coin we actually got because we have all the probabilities that we need. So we can split this up into the probability of getting 5 heads, given you have an unfair coin, times the probability you have an unfair coin. And we can think of this as kind of our A, our B, and our B. And then if we do the probability of A given B complement, well, what's B complement here? This is just picking a fair coin. That's the exact opposite of picking an unfair one. So this is going to be our B complement. And we already know what all these values are, so we can just plug this in and get 1 times 1 over 33 plus 1/2 to the 5 times 32 over 33. And then finally, we can plug all of these in and get the probability of picking that unfair coin, given we saw 5 heads, is equal to 1 times 1 over 33 times 1, or divided by 1 times 1 over 33 plus 1 over 2 to the 5th times 32 over 33. Simplifying this, we can cancel out all these 33s, and we get 1 over 1 plus 32 over 2 to the 5th, which ends up just being 1/2. So now if we try and do the general case, well, everything's going to be the same, except the actual values we use won't be numbers, they'll just be variables. So now instead of calculating the probability of an unfair given 5 heads, now we're just doing it K heads. So we're going to do unfair given K heads. And then we're applying the same Bayes rule as before. So this is going to be the probability of K heads given an unfair coin times the probability of getting that unfair coin again, all over the probability of getting K heads. Now I'm going to write out these probabilities, and we're going to do the same thing as last time. All right, so now that I've got these all written out, we can run through the actual probabilities. So the probability of getting K heads, given that we have an unfair coin, same thing as last time, probability of equal to 1. Now this is where it changes. If I have a fair coin and I flip it and get K heads, well, instead of raising it to the 5, I'm taking that same probability of 1/2 and raising it to the K. Now the probability of giving an unfair coin, well, that's going to be, we still have one unfair coin, but now instead of having 33, we have n coins. And the same thing, if we have n minus 1 fair coins, then this is going to be n minus 1 over n. And then for the probability of getting K heads, I did the same thing as last time. I expanded this and conditioned on what coin we got. And then we can just plug in and get the same probabilities as last time, where we have 1/2 times 1 over n plus 1 over 2 to the K times n minus 1 over n. And then finally, we can plug these in and solve and get the probability of picking an unfair coin given K heads is equal to 1 times 1 over n all over 1 times 1 over n plus, and then I'm going to simplify this again, n minus 1 times 2 to the K times n. Now, we can do the same thing as last time. If we factor out this 1 over n, we can cancel all of these n's and get 1 over 1 plus n minus 1 over 2 to the K. Then, just to check our work, we can plug in. Let's say our n was 33, like last time. K is equal to 5. Then we get 1 over 1 plus 33 minus 1 over 2 to the 5. And this is equal to 1 over 1 plus 32 over 32, which is 1/2, just like we had last time. So we did it correctly. And this is the general form for any type of question that has this Bayes rule. And I implore you not to memorize this formula. I think the important part of doing this general formula is understanding how you could apply this thinking to any type of question that has this format, and not just for the sake of, okay, well, I already know the formula. If I memorize this, I can just plug it in and be done. And I say that because a lot of questions follow a similar format, but aren't the exact same. So if you understand why this works and not just regurgitate it, then you will fare much better when you have a similar question and not one where you're only able to just plug it in. And then finally, an example of how you might get an extension of a question like this. They might ask you to do this problem, but they're not asking for the actual probability. Now they might be asking, if you have that problem, how many times would you have to see heads before being 99% confident that you have an unfair coin? So what we have right now is we're given n. And we know the probability of an unfair coin given k heads is equal to 1 over 1 plus n minus 1 over 2 to the k. And we want to know, when is this probability going to be greater than 0.99? Because that's what this is really asking. If you're 99% confident, that means the probability of it actually happening has to be greater than 99%. So if we take this and we're given an n, that means we could just plug it in, that we want to figure out what k would give us a probability greater than 0.99. So what are we doing? We're solving for k in terms of n and other constants. So just plugging back in, greater than 0.99, we can rearrange this and get 1 over 0.99 greater than 1 plus n minus 1 over 2 to the k. Again, if we subtract 1 from both sides, now we have 1, and I'm just going to say, because this is equal to 100 over 99, I'm going to say 1 over 99 is greater than n minus 1 over 2 to the k. And now we want to isolate 2 to the k. So I'm going to bring the 2 to the k over here and take 99 times n minus 1. And now, because n is guaranteed to be a positive integer, just because of the fact that you have to have a positive number of bags or coins, and 2 to the k is always positive, now we can take the log of both sides to bring that k down from the exponent. So if we take the log base 2, then now we get k is greater than log base 2 of 99 times n minus 1. And now this isn't guaranteed to be an integer, so if we want to find this final closed form solution, then we'll set k equal to the ceiling of this quantity. And now we have solved this question and given a k. You can plug this in, you can try a value. One value you might want to note is that if n is equal to 5, then k is going to be equal to log base 2 of 396. And if 2 to the 8 is equal to 256, then this is going to be equal to 9. So that means if I have 5 coins in a bag and I know one of them is unfair, I'd have to flip it 9 times before I'm almost 100% confident that that coin that I picked was the unfair one. But yeah, hopefully this was helpful. Hopefully this showed how you would approach a problem like this, and you understand this thinking and thought process so that if you see a problem similar or exactly the same, you know what to do. Awesome. Thank you.